Example 7.4 is going to walk us through a couple uses of the product rule. And it's called the product rule because it allows us to differentiate products. Let's remind ourselves of what it states. If we have a product of two functions f and g, and we want to differentiate this, we can differentiate only one at a time. So I will differentiate the first function first, and then I'll just copy down the g. I will not differentiate g. I'll then add to that the opposite of what I just did. I will add to that the derivative of the g function, the second function, and then I will copy down the first function without differentiating it. Here we have a product of two functions. So when we take a derivative, the derivative will be e to the 2s times a 2, because that's the derivative of this first term. We will then have s squared minus 7s, because that is the second term copied down without differentiating. We will then add to this the opposite of what we just did. So I will differentiate the second term, 2s minus 7. So that's taking the second term and differentiating it, and copying down the first term without differentiating it. All right, let's move through this second one a little bit faster. Here I have a square root, so I'm immediately going to rewrite that before I differentiate so that I can use the power rule. This is equal to natural log of x times 1/3 x to the 4th minus a 2x raised to the 1/2 power. The derivative of this, so this is not going to be equal to, the derivative of this will be, we'll differentiate the natural log first, we'll get a 1/x. We'll copy down everything inside the square brackets. In fact, the entire square bracket. We're going to copy down the second term. We will then add to that the copied down natural log, and now it's our job to differentiate that second term. So the 1/2 will come down. We have a 1/3 x to the 4th minus a 2x, now being raised to a power of minus 1/2, and by the chain rule, multiplied by the derivative of what's on the inside of those square brackets, 4/3 x cubed minus a 2. So that was a product rule that had a chain rule hiding inside of it. Here for C, we need to rewrite this again because it doesn't really look like a product to me. But we can take the x minus 1 and multiply it by x plus 1 raised to the minus 1. And now we have a product rule. So the derivative will be, let's differentiate the first term. And if I differentiate x minus 1 with respect to x, I just get a 1. So I'm going to write that, even though we kind of don't need it. Multiplication by 1 doesn't change anything. But that's the derivative of the first term. The derivative of the second term. Ooh, sorry. I almost made the mistake, right? I'm not supposed to differentiate the second term. I'm just supposed to copy it down. All right, now I add to that the copied down first term and the differentiated second term. All right, and we should clean that up a little bit. So this will be equal to 1 over x plus 1 plus, oops, let me see, that plus, but that minus 1 will turn it into a minus. Minus an x minus 1 over x plus 1 squared. Okay. And let's move on. D. Here, this will differentiate to 3 square root x minus x. So here I just copy down my first term, I'll need to differentiate the second term. E to the 1 minus x times a minus 1. I'll add to that the opposite of what we just did. So now it's time to differentiate this term. 3 over 2 x to the minus 1 over 2 minus a 1. And then we'll copy down the second term, e to the 1 minus x. So notice in A, B, and C, I stuck with that pattern. I would differentiate the f function, the first function on the left, first. But you don't have to do that because multiplication is commutative, or rather addition is commutative. So the important pattern is you just differentiate one of the functions first and you leave the other one alone. For instance, down here at D, I didn't differentiate the first term first. I just copied that one down. I differentiated the second term.